Okay, so for 3.2 notes, we are going to solve systems of equations algebraically. And we're going to first start out by writing this stuff. So there's going to be kind of a lot of writing. So you'll probably have to pause the video to get everything written down. Step one is going to be to solve for a variable, meaning you're going to either get x or y alone. So for example, if you're looking down here, you can choose to get this x alone, this y alone, this x alone, or this y alone. So it's your choice, but you're just going to get a variable alone. Once you have that variable alone, you're going to plug the expression into the other equation. So if you have x equals blah, 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 you're going to plug blah, blah, blah into the other equation. So for example, down here, if you solved for a variable in equation A, once you have that expression, you're going to plug it into equation B. Okay? You may remember doing this from Algebra 1. Once we have that plugged in, we're going to solve that equation. This will be like the review problems from the 3.1 homework, because you'll have an equation that is in one variable, and you're going to solve the equation and find that variable. You're going to solve for that variable. The next step is going to be, once you do step 3, which is to solve that equation, you're going to have x equals a number or y equals a number. So now that we have one of the variables, you're going to plug the known variable into either of your original equations. So you'll have the value of either x or y. So you'll be able to plug it into either A or B. It does not matter which one you plug it into. And then you're only left with one variable. So you're going to solve the equation. To find that other variable. Once you have both the x and the y, you're going to write your solution as a coordinate point. So you're going to write your solution as x, y. Once you have your solution, what you're going to do is you're going to plug in your solution to check. And I'll show you how to do that as well. So, once you have those steps written down, we're going to move on to finding the solution to these three systems. So starting with number 1. I'll number them. Example 1 says to solve each system by substitution. Check your answer. State whether the system is independent, dependent, or inconsistent. Okay, so if we're able to find a solution, we'll know that that graph, if we were to graph it, would cross at that one point that we write as our solution. If that's the case, it's an independent system. If we're not able to find a solution, meaning the variables disappear when we're solving, then we'll know that it's either dependent or inconsistent. So it's either parallel lines or the same line. And I'll show you once we get there how to determine if it's dependent or inconsistent. So starting with number 1, I would first choose to solve for the variable y in A. The reason? Because you don't have a coefficient on y where you'd have to divide. Your coefficient is already 1. So what we're going to do is we're going to get y alone. So I'm going to write my equation A is y equals negative 3x plus 3. I would subtract 3x on both sides to get y equals negative 3x plus 3. Now, plug the expression into the other equation. Since this is from A, we are going to plug this expression here in for y in the B equation. So we have 2x minus 5. Instead of plugging in y, or instead of writing y, we're going to plug in negative 3x plus 3. I always write out my equation first with the parentheses in place of y so that you don't forget parentheses. It's very important to put parentheses. You'll see why here in a minute. Okay, so now what we're going to do, it says to solve the equation. You'll notice that this equation is just in terms of x. There's only x terms in this equation. So we're going to be able to get x by itself. The first thing that we're going to have to do is distribute that negative 5. Once I distribute that negative 5, I'm going to combine like terms. I'm going to move the constants to one side. What happens, though, is on the right side, negative 15 plus 15 becomes 0. But that's okay. I can still keep solving. I'm going to divide by 17 on both sides. On the left side, I'm left with just x. On the right side, 0 divided by 17. If I'm not sure what that is, I can grab my calculator, type it in. 0 divided by 17. The answer is 0. So now I know that my x variable is 0. So for my solution, I know that this is going to be a point, and I know that the x coordinate in my point is going to be 0. Now, it says to plug the known variable into either original equation. So at this point, you can plug it into A or you can plug it into B. It doesn't matter. So I'm going to plug it into A. 3 times 0 plus y equals 3. Well, 3 times 0 is 0, so I have 0 plus y equals 3. You could subtract 0 from both sides, but you're still going to be left with y equals 3. So that's the y coordinate of our solution. Our solution is 0, 3. Now we're going to check to see if this is correct. I'm going to show you how to do this on your calculator, because you can do it on your calculator. It makes it very easy. But the cool thing about this quiz is if you're checking your solution and you know how to check your solution, you'll actually know whether you have the correct answers or wrong answers before you hit submit on your quiz. So it's very important that you do know how to correct. I would recommend checking, because then if you know you got it wrong, find your error and fix your mistake. So for equation A, 3 times our x value is 0. 3 times 0 plus our y value is supposed to be 3. When I hit equals, I should get 3 here. 3. Now, depending on if these are in standard form or slope-intercept form, we might have to type them in differently. So I'll show you every time how to type these in. 2 times our x value is 0, minus 5 times our y value is 3, equals, and we get negative 15. So I'm confident that our solution is correct, because when I plugged it in for A, it worked, meaning it's a solution of A. When I plugged it into B, it worked, so it's a solution of B. In order for it to be the solution to the system, it has to be a solution to both equations. If it doesn't work, somewhere in your work went wrong, and you want to go back and find it. Okay. Since we were able to come up with a solution, the type is going to be independent. There is one solution, so that is an independent system. The next one, number 2. The first thing we're going to do is solve for a variable, meaning to get x or y alone. You'll notice, though, For B, x is already alone. X equals 3y minus 22. So step 1 is already done in this case. Step 2 says to plug that expression into the other equation. So we're going to use the expression 3y minus 22 in place of x. So I'm going to write this. Remember I said use parentheses. So x minus 3y equals negative 4. Then I'm going to go back and fill in my expression. I like to do it this way so I don't miss anything in my equation. My expression is 3y minus 22. Notice there are no x's now in my equation, which is exactly what we wanted. So I'm going to move on. I don't have anything to distribute, so I can rewrite this without parentheses. Next, I'm going to combine like terms. 3y minus 3y is 0y. So your y's actually go away here. On the left, we're left with negative 22 equals negative 4. From this point, I can see that there's no y to solve for anymore. Some people from this point move on and they add 22 to both sides. That's totally fine. It's not going to make a difference. If I added 22 to both sides, I'm going to get 0 equals 18. Either way, whether I'm looking at negative 22 equals negative 4 or 0 equals 18, is that true? It's not true. It's false. And because of that, it will never be true. You'll never be able to plug something in and get it, find the value. So what this tells us is that there's no solution. So right away, we can move on to writing our solution is no solution. Just like we did when lines were parallel, we wrote no solution. The type is then going to be the same type when the lines were parallel, which was inconsistent. Now there's no way to plug this back in and check, other than what you could do is you could convert both of these to a y equals equation. So you're looking at it in the form of y equals mx plus b. And notice if they have the same slope and different y-intercepts, that yes, your lines would be parallel, meaning no solution and an inconsistent system. Now, let's move on to the bottom part, because when there are no variables and the remaining statement is true versus false, okay? If it was true, you would get an answer something like 0 equals 0 or 4 equals 4, okay? Either way, it doesn't matter. You'll have a number equal to itself. This will tell us that you'll have infinitely many solutions, because this one would be the lines are the exact same. So you're going to have infinitely many solutions. It's a dependent system. So your solution is infinitely many solutions. The type is dependent. Now if it's false, that's what happened up here. So this would be something like if you had 0 equals 10, or 2 equals negative 2, or something along those lines that you know is a false statement. If that is the case, your solution is no solution. Your type is going to be inconsistent. Make sure when you get to here, you don't tell me that the solution is false. Okay, that's not the case. This being a false statement tells us that we have no solution. All right? So, let's try example number 3 here. So for this one, the first step says to solve for a variable, get x or y alone. So I like to find the easiest one to get alone. This one, it looks like A, getting x alone would be the easiest choice. So using equation A, I'm going to solve and get x equals negative 5y plus 3. I'm showing you how to tell me which equation it came from, so you then know that this has to plug into equation B. It's also going to help once we move on to 3 equations, which we do next unit, if you get in the habit of writing it this way. So we're going to plug in x for equation B. So for equation B, we have 3 times x minus 2y equals negative 8. The x value, what we're plugging in for x, is negative 5y plus 3. Now we're going to take a look, and we only have y in here, which is good. We're going to have to distribute that 3. You'll want to combine like terms. You'll want to take the numbers and get them all on the other side. Now you'll have to divide by negative 17 on both sides. And you'll find that y is positive 1. We plugged it in, we solved that equation, plugged the known variable. Okay, so here we go. Here's our solution. We're going to start writing it out. We know y is 1, so I'm going to write that in there. And the type, since I'm able to find this, I already know that my type is going to be an independent system. Okay. So now that I have y, I'm going to plug that part back in. It doesn't matter if you want to plug it into A or into B. Maybe you'll plug it into A. X plus 5 times 1 equals 3. X plus 5 equals 3. Subtract 5 on both sides. And you get x is negative 2. So our solution is negative 2, 1. Okay, so we're going to plug it back in to check. Now, this one is very similar to the last one we had where they're both in standard form. So I'm going to show you something in addition once we get it plugged in. So x is negative 2 plus 5 times y is 1 equals, we get 3. We're in the clear. 3 times x is negative 2 minus 2 times y is 1 equals, we're supposed to get negative 8, and we do, we're in the clear. Now, let's say one of your equations was not in standard form and it looked like this. Okay? You're going to have to type in the left side and the right side separately. So this is just another version of equation A, so it should also work in this equation A. So I'm going to show you how you're going to type it in. The left side is negative 2. Hit enter. Negative 2 has to match with when we plug it into the right side. Negative 5 times our y value is 1 plus 3. So our left is negative 2 and our right is negative 2. Negative 2 does equal negative 2, which is a true statement, so it is a solution. So that's how you would do it if it wasn't in standard form. But you should still be plugging everything in to double check all of your answers. That's as far as we're going to go on the notes today, because I want you to focus on assignment number 1, which is just substitution. Okay? Now notice, something like this, it's already skipping a step because this equation here doesn't even have an x in it. So you already have one of your variables from the very beginning. So I just wanted to point that out to you. Some of these already have a variable that's solved for. So for example, number 1, y is already solved for. So that's probably going to be step 1 is already done for you. Okay. When you get to number 3, you'll have to solve for a variable. You'll have to actually perform step 1. The back side of this does have a story problem on it. So I'm going to walk you through how to set up that story problem, because usually the story problem is kind of scary. It says write a system of equations to model the donation y for x miles bite. So since we're going to be writing a system, you know that you're going to have two equations here, an A equation and a B equation. So let's read the scenario and figure out what's going on. It says, suppose you have signed up for a bike-a-thon to raise money for charity. One person is sponsoring you at a rate of 50 cents per mile. Each of the other sponsors plans to donate $15 no matter how far you bike. So our system has to be an equation to model the donation y for x miles biked. So we have two different donation types. We have a donation that's per mile and a set donation. So y is the amount donated. So I'm going to underline this one in blue because I'm going to write that equation in blue. And I'm going to write this equation in pink to help us kind of separate these. So the first one says to write a system of equations. Y is the money made, and X is the miles biked. So they're sponsoring us at a rate of 50 cents per mile. Now remember when I said back in Unit 2, if you see the dollars per mile, per means that that is a slope. So if we're writing this in the form of y equals mx, we know that it's y equals, our rate is 50 cents per mile times the number of miles. So that would be our first equation. Our second equation, each of the other sponsors plans to donate $15 no matter how far you biked. So they don't even care what x is. They're just telling us that y, the amount they're going to donate, is equal to 15 always. The end. There's nothing more to it. Okay? So us doing part A together, you should be able to then figure out part B, because now you have a system and you have to go and solve it. If you have any questions, let me know.